We've never seen this before. Scientists say the magma chamber under Mount St. Helens in Washington might be expanding. That sounds a little scary, but let's explore it together in a simple way so we can understand what scientists are really seeing and why they are paying close attention. Have you ever wondered what it would be like to stand near a giant volcano? A mountain so powerful it can shake the ground, light up the sky, and send ash high into the air. In the US state of Washington, there is a famous volcano called Mount St. Helens. It may look quiet today, but inside the mountain, something very interesting might be happening. Mount St. Helens is not just any mountain. On May 18, 1980, it erupted in one of the most powerful volcanic explosions in American history. The blast knocked down forests, sent ash across several states, and changed the shape of the mountain forever. Because of that eruption, scientists now watch Mount St. Helens very carefully. Today, the mountain looks calm, but scientists from the United States Geological Survey, also called the USGS, use special tools to watch what is happening deep underground. They use earthquake sensors, satellites, and gas monitors to see clues that people cannot see with their eyes. Recently, scientists noticed something important. Deep under the volcano, there is a place called the magma chamber. This is like a big pocket of melted rock inside the earth. Magma is extremely hot, hot enough to melt solid stone. Scientists think the magma in this chamber might be slowly moving and possibly getting bigger. That doesn't mean the volcano is erupting right now, but it does mean the inside of the mountain is changing. And that makes scientists curious and careful. Sometimes volcanoes give small hints before they erupt. These hints can include tiny earthquakes, ground swelling, or changes in gas coming out of the mountain. Scientists watch all these signals so they can warn people if something more serious might happen. Right now, Mount St. Helens is still quiet on the outside, but deep inside, the story of the volcano may still be unfolding. So what exactly is happening in the hidden heart of this mountain? And could Mount St. Helens surprise the world again someday? The blast that changed everything. Let's go back to the biggest, loudest, and most unforgettable chapter in Mount St. Helens' story, the eruption of May 18, 1980. It was the 18th, not the 19th, when the main explosion happened. Before that day, most people thought of Mount St. Helens as just another beautiful, snowy mountain. But deep inside, something was stirring. Magma was rising, slowly pushing up, making the ground tremble and the sides of the volcano crack. Then, with little warning, the north side of the mountain slid away in a huge landslide, the largest in recorded history. Right after that, the volcano exploded. Imagine hearing a sound so loud it shakes your bones, and looking up to see the sky fill with clouds, not of rain, but of dark, thick ash. The day turned grey for miles around. The eruption didn't just spill a little bit of lava, it blew the top off the mountain. For hours, ash poured out, blanketing cities and towns underneath. It wasn't snow, it was gritty volcanic ash, so fine it drifted on the wind for hundreds of miles. Cars struggled to drive, and people had to protect their faces from the thick dust. For days, people watched their cities go quiet under a layer of grey, wondering, is Mount St. Helens finished? Or could something like this happen again? But when the dust started to settle, scientists rushed to the mountain. They wanted to figure out what happened. They realized Mount St. Helens wasn't just a stunning landmark. It was a living volcano, a powerful reminder of how quickly the Earth can change. That day in 1980 changed the way people saw volcanoes everywhere. Suddenly, students were learning about it in school, scientists were writing books about volcanoes, and the world was watching to see what would happen next. Even now, the forest that was flattened is still growing back, and the effects of the eruption are a living reminder that our planet is always moving under our feet. But the 1980 eruption wasn't the end of Mount St. Helens' story. It was just the beginning of a new chapter, one that is still unfolding today. The strange signs beneath the ground. Fast forward to today. Mount St. Helens looks peaceful at first. White snow on top, green trees around the sides, clouds floating by. But, as every volcanologist knows, volcanoes are rarely as quiet as they look. The earth under the volcano always has stories to tell. Scientists started to notice subtle changes at Mount St. Helens. Tiny earthquakes, so small they could only be detected by the equipment scientists use. These small tremors are a volcano's way of hinting that something is changing. Earthquakes like these almost always mean magma is moving inside the earth, pushing through cracks and shifting the rock. The experts of the USGS keep busy, watching Mount St. Helens with a whole set of high-tech tools. Some scientists hike up steep trails with gadgets and sensors, collecting samples by hand. Others stay farther away, using computers to track the smallest rumble from under the earth. With every bit of data they collect, they are piecing together Mount St. Helens' secret. In September 2025, something strange happened. Giant plumes, looking like smoke or ash, suddenly appeared over Mount St. Helens. People got worried, remembering the disaster stories from 1980. Reporters crowded the area. Helicopters buzzed overhead. Even animals acted nervous, as if they sensed a change. But the USGS quickly explained, these were not ash plumes from an eruption, but large clouds that could have been caused by steam, dust, or landslides. Not every puff from a volcano means a blast is coming. Sometimes, volcanoes release gas or steam as magma shifts deep below. Still, the question remained, if there wasn't an eruption, what was happening underground? Why was Mount St. Helens sending all these signals now? How did they find the magma chambers? How do you take a look inside a mountain without drilling all the way through it? That's where the power of science comes in. Scientists use networks of seismometers, machines that listen to the smallest movements under the ground, and GPS sensors to measure even the tiniest rise or shift in the Earth's surface. When magma moves, it changes the way the ground shakes and swells, and scientists can sense it all. In recent years, thanks to seismic tomography, a bit like taking an X-ray or an MRI of the Earth, scientists got a better picture of what's underneath Mount St. Helens. To their surprise, they found not just one, but two main zones or chambers where magma moves and collects. One is a large chamber beneath the volcano at depths of about 5 to 12 kilometers, 3 to 7.5 miles. This upper chamber, in turn, is fed by even deeper regions, like a two-level set of homemade lava rooms beneath the mountain. These chambers are not always filled with liquid magma all at once, but they are places where the molten rock can collect, move, or build up pressure over time. But here's what's really caught the scientists' attention recently. By measuring the subtle swelling of the ground, combined with data from tiny earthquakes, they realized that the upper magma system seems to be expanding. That suggests more magma may be entering the chamber, or pressure is increasing, a classic sign that the volcano's inner workings are in motion. Scientists look for other clues too. They test gas seeping from cracks, sample the temperature of nearby streams, and analyze minerals for any sign that new, hotter magma is moving upward. All these hints help them build a picture of what's going on beneath the volcano's calm surface. Why is the magma chamber expanding now? Does this mean another eruption is on the way for Mount St. Helens? Or is it just part of a restless volcano's unpredictable cycle? What happens when magma moves? Let's imagine what's happening under the ground. The magma chamber is like the volcano's hidden stomach, deep, dark, under huge pressure. When more melted rock seeps in from below, it fills the chamber, almost like a balloon being filled. Only this balloon is made of solid stone and is much, much hotter and heavier. As the magma moves in, it pushes at the rocks surrounding the chamber, sometimes bending or cracking them just a little. These shifts create tiny earthquakes. Every tremble that a seismograph records helps scientists figure out exactly where things are moving below. If enough magma enters the chamber, or if enough pressure builds up, the ground over the chamber can start to bulge. Some GPS sensors on Mount St. Helens have detected tiny rises in the surface, showing the remarkable power of magma, even from deep inside the Earth. Sometimes, if the pressure gets high enough and the magma finds a path to the surface, it can form a lava dome, a mound of cooled lava that slowly rises inside the crater left after a big eruption. Mount St. Helens grew a new lava dome over many years after the 1980 blast, sometimes quietly, sometimes oozing or steaming. But magma movement doesn't always lead to a dramatic eruption. Sometimes it just shifts around and finds its own balance, letting off heat and gases in small bursts. Other times, as history shows, the signs all point to a big event, just like in 1980. Scientists watch for every clue, wondering, is pressure building up for something big, or will the mountain simply settle down again? USGS scientists clarify that while the magma system is dynamic and magma has been moving, there is no evidence of an entirely new magma chamber. And, based on careful monitoring, they say Mount St. Helens is not currently on the verge of a major eruption. Still, they watch closely because volcanoes can sometimes surprise even the experts. Are we safe from another big eruption? Hearing about magma moving and chambers expanding might sound scary. Can people near Mount St. Helens sleep soundly at night? Is it safe to visit the forests and lakes on its slopes? Here's what volcano watchers know. The USGS and partners keep a constant eye on Mount St. Helens, using satellites, sensors, cameras, and robots to pick up every quake, every puff of gas, every odd movement. If a major eruption was likely, the scientists would alert everyone quickly, just as they did in the past. In September 2025, when those giant plumes appeared, the USGS reassured the public, it's not erupting. But they also explained why everyone should stay alert. Volcanoes have their own rhythms. Sometimes they cough a little, sending out steam, ash, or even having a minor eruption, like the one that happened at Mount St. Helens in 2025. While this minor event didn't compare to 1980, it was still a reminder that the mountain is active. People who live near the volcano often keep emergency kits handy. Local schools and families practice what to do if the scientists ever issue a serious warning. Everyone near the volcano knows it's better to be prepared, just in case. Nature around Mount St. Helens keeps recovering. After the 1980 eruption, whole forests were knocked flat, and lakes turned to slime with ash and fallen trees. But over time, wildflowers bloomed again, birds returned, and new forests began to grow. Even today, biologists use Mount St. Helens as a living laboratory to study how wilderness recovers after disaster. So, are we safe? With scientists monitoring every moment and clear plans for emergencies, people can feel confident. Still, as every scientist will admit, volcanoes sometimes have the final say, and nature is always full of surprises. Will Mount St. Helens surprise us again? So now we wait and watch. What if that expanding magma chamber is the sign of a coming eruption? Or what if it simply means the volcano is going through one of its many restless phases with no big eruption in sight? Geologists, the rock detectives, are cautious. They say finding a dual system of magma zones helps explain how eruptions happen and may help predict the volcano's future. But, and this is important, there is no evidence, as some rumors claim, of a brand new magma chamber that signals immediate danger. The mountain's magma system is always changing, growing and shrinking over time. People have noticed that sometimes animals on the slopes, like deer and birds, act a little differently before an eruption. Sometimes rivers warm up and plants grow in odd new patterns when the heat below changes. All these little shifts and clues are part of the puzzle Mount St. Helens offers. But even scientists, with all their equipment and data, cannot always say with certainty what will come next. That's what makes volcanoes like Mount St. Helens so fascinating, and sometimes a bit unnerving. When warning signs appear, the world's eyes turn back to the mountain, waiting for the story to unfold. Could some clues be hidden deep below? Let's journey deeper, down into the heart of the volcano, where it's pitch black and so hot that rock is as runny as syrup. The magma chamber lies hidden, feeding gas and heat upward through cracks in the mountain. Sometimes a little steam or gas sneaks out, making those plumes that spooked everyone in 2025. Sometimes the magma presses harder on the rocks, causing small earthquakes. To find out what's happening, scientists depend on their special tools. Seismographs listen for earthquakes to track magma's movement. GPS sensors spot minor bulges or shifts in the land. Cameras and satellites look for new plumes or heat spots at the surface. Studying these clues, researchers now have a better map of Mount St. Helens magma system. Two main chambers, one deep and one shallower, linked by channels of melted rock. When both are filling, pressure rises. When they empty, the volcano gets quiet. Scientists even check the water in nearby lakes and rivers. Sometimes it gets warmer when heat rises from below, or fish and plants act a little differently. Every piece of information adds to the puzzle, helping scientists protect people nearby. Will Mount St. Helens stay a mystery? Even after years of study, Mount St. Helens keeps some secrets. We know more than ever about how magma moves, how the ground shakes before an eruption, and the signs to watch for. Computer models and real-time sensors help, but nature is always one step ahead. Will Mount St. Helens erupt again like it did in 1980? Or will it just rumble and puff every now and then? Scientists don't know for sure, and that's why their work is never finished. Every volcano is different, and each one keeps its own mysterious signals. What's certain is that people who visit the mountain today can walk through spots where the forest was burned away and see nature coming back. Wildflowers growing where trees once stood, birds and insects making new homes. There are visitor centers and science exhibits where you can learn about how the eruption changed the world and how the earth beneath our feet is alive and moving. As scientists keep watching and as people keep wondering, the story of Mount St. Helens continues to unfold. The main magma chamber may expand, shrink, or stay the same. The volcano may stay quiet for years, or one day surprise us again. So next time you see Mount St. Helens' snow-capped peak shining in the sun, remember, just beneath that peaceful surface, a world of heat and pressure is still shifting. The story isn't over. The adventure carries on. Mount St. Helens keeps her secrets for now. The mountain stands silent above, while deep underground, the magma system continues its quiet dance. Scientists watch and listen. People and animals live nearby, enjoying the beauty and preparing, just in case the mountain ever whispers a new secret. And that is the story of Mount St. Helens, a volcano with a restless heart, full of mysteries, and always ready to surprise.